Okay, AP Calculus. We are going to review the first and second derivative test. Okay, there will be more videos to follow, so I'll keep adding to this, but this will be part 1. Okay, and what we're going to start off with is just a polynomial. All right, let's take the function f of x equals 2x to the 4th minus 4x squared plus 1. Now, this is just a regular polynomial function, so I'm going to start by just taking the derivative. That would be 8x cubed minus 8x. All right, second step's going to be to set that first derivative equal to 0, factor out any like terms, and I get x squared minus 1. Keep factoring, and I get 8x, and then x plus 1, x minus 1. All right, now, I have 3 critical points. Critical points occur where the derivative equals 0 or where it's undefined. This derivative will never be undefined. So my critical points are x equals 0, negative 1, and 1. These are my critical points. So I'm going to draw a number line, which is going to be my sign diagram. I'm going to put negative 1 here, 0 here, and 1 here. All right, so I'm going to take these points, and I'm going to choose points around them, values for x around them. Let's choose negative 2. Let's choose negative 1/2, 1/2, and 2. And I'm going to be plugging these values into the derivative. Okay, so if I were to plug negative 2 into this, that would be a negative times a negative times a negative. And that's going to be an overall negative. If I were going to put negative 1/2 in here, that would be a negative times a positive times a negative, which would be a positive. If I put a positive 1/2 in here, that would be a positive times a negative, which would be a negative. If I put 2 into here, that would be plus, 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 which is a positive. All right, so now I know some things about f of x. First of all, f of x is decreasing on the interval negative infinity to negative 1, union 0 to 1. And because the derivative is less than 0 on those intervals. Sorry, that's a mess. Intervals. Okay. Now, f of x is increasing on the intervals where the derivative is positive. That's going to be negative 1 to 0, union 1 to infinity. Okay? Why? Because the first derivative is greater than 0 there. Now, I'm looking for maxes or mins. So f of x has a relative minimum at x equals what? Minimum occurs when you change from decreasing to increasing. So we've got a relative minimum at x equals negative 1 and at x equals 1. Why? Because the derivative changes from negative to positive. Okay, let's move up just a little bit more. And then f of x has a relative max at x equals 0, and that's the only place. It goes from increasing to decreasing because the derivative changes from positive to negative. Okay? Now let's look at concavity. So let's take this first derivative here, and we're going to find the second derivative. All right, so let's go ahead and write this up here. The first derivative, okay, was 8x cubed minus 8x. Let's take the second derivative, and that's going to be 12x squared minus 8. And I'm sorry, that is not right. I cannot multiply today. So sorry. That's going to be 24x squared minus 8. All right, set that second derivative equal to 0, factor out, and I'm going to factor out an 8. 8 goes into 24 3 times. Okay, so that's what we end up getting. 3x squared minus 1 after we factor out an 8. Now, here is where my derivative is going to equal 0. So 3x squared minus 1 equals 0. 3x squared equals 1. X squared equals 1/3. So x equals plus or minus the square root of 1/3. Okay, so these are my critical points for the second derivative. Second derivative tells me possible points of inflection. It also tells me concavity. So I'm going to do a sign diagram for the second derivative. And I'm going to put a negative square root of 1/3 and a positive square root of 1/3. Now, even though you don't know what the square root of 1/3 is, you don't need to know it because you just need test points. And I certainly know that 0 falls in between here. Square root of 1/3's got to be a small number because the square root of 1 is 1. So I'm going to choose 2 on this side and negative 2 on this side. I'm going to plug these test points into my derivative. So plugging in negative 2, I get a positive. Plugging in 0, I get a negative. And plugging in 2 into the derivative, I get a positive. All right, therefore, I know some things about f of x even more detail, not just max or mins and increasing and decreasing. Now I know that f of x is concave down on the interval from negative square root of 1/3 to the square root of 1/3. And I know that f of x is concave up from negative infinity to negative square root of 1/3 union square root of 1/3 to positive infinity. So now I know where it's concave up and down. I also know that there are some points of inflections. So f of x has points of inflection at x equals negative square root of 1/3 because there's changes in concavity there, and at x equals square root of 1/3 because it changes in concavity again. Okay, I'll be posting more videos later of first and second derivatives test.